Good day friends, welcome to my channel lecture series on power electronics. In this lecture, we are going to learn about regulated power supplies, generally referred to as RPS. The block diagram of a regulated power supply is shown in this picture. A regulated power supply is an electronic circuit which produces a steady DC output voltage at the load terminals from a fixed value of AC input voltage. Irrespective of the changes in the load values, the output remains as a steady DC voltage. The essential parts of a regulated power supply are a transformer, which is a step down transformer, a rectifier, a filter, and the regulator. The AC input voltage is stepped down to a required AC voltage by the transformer. The rectifier, it is an uncontrolled rectifier here as shown. It has got 4 diodes, and the AC input voltage available for the rectifier from the transformer is converted into a DC voltage, and that DC voltage is filtered using a filter circuit. Then the output of the filter circuit is given to a regulator where the voltage is made as a steady voltage irrespective of the change in the load side. The voltage waveforms available at various points of the RPS is shown in this picture. The AC input voltage is a sinusoidal waveform as shown here, and the step down transformer steps down the AC input voltage to a required AC input voltage, which is also sinusoidal in nature. The rectifier converts the AC input voltage into a unidirectional voltage, which is also referred to as a direct voltage, but it has got ripples, and these ripples are filtered using a filter circuit, and the output has got less ripples as shown here. Then the ripple content in the voltage, which is a unidirectional voltage, is given to the regulator, and from the regulator we get a pure DC voltage which is given to the load. Irrespective of the changes in the load voltages or load terminals, because of the presence of the regulator, the output voltage from RPS remains as a steady DC voltage. The voltage regulator used here takes care of the variations in the input voltage or the variations in the load side. Whatever happens, the output voltage is maintained constant because of the regulator. Some of the features of the regulated power supply are: the regulated power supplies have an efficiency ranging from 20 to 25%. They are relatively more reliable. They have less complex circuit and less weight. They give faster response. The cost and noise level of the regulated power supplies is low. Regulated power supplies find applications in the mobile charging circuits, testing circuits, bench power supplies, oscillators and amplifiers, electronic computers, automatic control systems, etc. There are two important terms associated with RPS. One is line regulation, other one is load regulation. Line regulation is the ability of the power supply to maintain a constant output voltage despite changes in the input line voltage. A good regulator minimizes the impact of input voltage fluctuations on the output voltage. It is often expressed as a change in the output voltage for a given change in the input voltage, sometimes as a percentage. Load regulation is the ability of the power supply to maintain a stable output voltage as the load current changes. For example, if the power supply provides 5 volts at no load, and when the load is connected to the output voltage drops to 4.9 volts, the load regulation is how much the voltage changed with the load change. It is often expressed as a change in the output voltage for a given change in the load current, sometimes as a percentage. Thank you. Hope this lecture has given a proper insight into the working of a regulated power supply.